Alright, so I'm going to show you how to work these problems out. So you can use this little square. No, it's not going to be on the test. To figure out what calculations you got to do. So, like, before I start, I trust that y'all could just read through these little slides that have the information in here, so you don't have to watch me or hear me speak, because you've done that long enough. So I'm just going to do a couple examples where you got to do these calculations. So these are all the equations right here. So like what this is saying is for any, the hydrogen, if you want to find the hydrogen ion concentration, you use 10 to the negative pH, and that'll give you the concentration. So remember, concentration is molarity. So whenever you solve for these, your unit is big M. So like, for example, a problem could be like, I want to find what's the hydrogen concentration of like HCl with a pH of like 2.7. So like hydrogen ion concentration just means acid. So since HCl is an acid, we do 10 to the negative 2.7 and you get the hydrogen ion concentration. You can use this equation. So what this states is your hydrogen ion concentration times your hydroxide concentration equals 1.00 times 10 to the negative 14th at 25 degrees Celsius. Any other temperature? You want to learn about that? Take my class next year or your senior year. And we'll see different temperatures. You could also, so like if you find, like right up here, we have the pH. If I wanted to find the POH, which as you saw in the slides, POH means power of hydroxide. It tells you how much hydroxide concentration. So the relationship is the opposite. If the pH is low, then the POH is going to be high. The POH high means it's not as much hydroxide. I know, odd land. So like if I wanted to find the POH of HCl, you would just do 14 minus 2.7, and then you would get your POH value. Alright, so again, you can kind of like use this little square right here. It tells you the direction of how to do things. You're just plugging and chugging things for today. So like if I wanted to find the pH, from here, if I wanted to find the pH, I would do 14 minus POH, give me pH. If I wanted to find the hydroxide concentration, hydrogen concentration, you do 10 to the negative pH, and then boom. If I wanted to find OH, follow this arrow, do this equation. And all these equations are on the back of the periodic table, so you should be good. You want to go backwards, pH, POH, POH equals 14 minus pH, voila. That's really it. So this key's posted if you want to look through it, but like I'll do a couple. I'll just set it up and you can check the answer on Canvas because I'm in my kitchen. I don't have a calculator, and yeah, don't feel like go getting one. So this is asking what is the pH of a solution with HCl with a concentration of 5 times 10 to the negative second. So all you do is negative log of 5.00 times 10 to the negative second, and then there's your pH value right there. So another indicator too is if this number is really low and it's asking for pH, it's generally going to be acidic. If it's really low and it's asking for POH, it's going to be basic. All right, so like 3. If I want to find the pH of this, again, if we do negative log of this right here, it's a base. So if I do negative log of this, that's going to give me POH. But the question is asking me for pH. So once you find POH, which we just did, then you're going to do 14 minus your POH, and you're going to get your pH value. So you just got to be careful what you have, because if you do negative log of that, it's going to give you a really low number, and NaOH doesn't have a really low pH. It has a really high POH because it's basic. All right, here's one where you got to do that equation with 1 times 10 to the negative 14th. So remember, for this one, it's asking the hydrogen ion concentration given the hydroxide concentration of that. So remember, this equation Okay, so all you do is plug in 1.90 times 10 to the negative third into the equation, and you solve. So it's basically this. Sorry, I'm not going to write the same exact number because I don't have any room. And that's going to give you your hydrogen ion concentration. All right, so sig figs, again, is important. So this is 3 sig figs. So if I wanted to find the pH of this, you do negative log of this. And remember your pH, I'm just going to put a random number here. It's probably going to be, it's not even near close. So let's say this is the number I get. This would be 3 sig figs because this is a characteristic. This is describing everything that has a pH of 2. So that's why we don't really count it as sig figs. Who made up these rules? I have absolutely no idea. That's why they didn't teach me that in college. They teach me all this stuff. So this would be 3 sig figs right there. And that's it. So if you do like down here at like number 6, what's the POH? If you do negative log of this, remember HCl is just hydrogen ion concentration. That'll give me pH. But I don't want pH, I want POH. So I gotta take this number and do 14 minus the pH to get me a POH. And it would be really high. Because remember the relationship, low pH is acidic, low POH is basic. So like number 9, what is the molarity? That's just hydrogen ion concentration. So you just do this. And then this would give you the concentration. Or you could write it as this. Okay, I think you can handle it on your own now. If you have any, check the key. If you have any questions, shoot me a mind. I'll be on school campus. I might pop my head in to spy on you if I have time. But